Okay, add a resistor, click here, resistor, place it here, voltage source, okay, ground, and diode, okay, simple diode. Rotate, you can rotate, okay, very good. And join the nodes, click here and also click here, very good, click here and here, very nice. Okay, modify the voltage source, select and adjust to 0 volts, 0 volts. Zero volts, and click on the diode, adjust. By default, saturation current 1 femtoampere, ohmic resistance 1 ohm, emission coefficient 1, and junction capacitance 5 picofarads by default. Okay, and run transient. Now you can see 0 volts on voltage source, 0 volts on resistor, 0 amperes on the circuit, 0 amperes on diode. Okay, take note of these values. Voltage source, diode voltage, okay, and diode current. Okay, the voltage source is 0 volts, diode voltage 0 volts, diode current 0 amperes. Okay, very good. And increment the voltage source, adjust. Here. 250 millivolts. 250 millivolts. Okay. So voltage source is 0.250. Okay. Diode voltage, as you can see, I will use a voltmeter. Okay, voltmeter. Click here. You can rotate. Down here, rotate. Okay. I want to know the voltage on the diode. Okay. Click here. Click here. This node and this another node. Very nice. Okay, and run transient. Okay. voltage source 250 millivolts is this 0.250, very good. Diode voltage is this, the same, 250 millivolts, 0.250. And diode current 0 amperes, 0. Now increment 250 millivolts more, okay, plus 250 millivolts. Adjust. And 500 millivolts. 500 millivolts. 500 millivolts and voltage source 500 millivolts is 0.5. Diode voltage 500 millivolts, 0.5. And diode current is 223 nano amperes. Okay, equal 223 and 10 okay equal 223 times okay 10 to the power of minus 9. Enter. Okay, is this number? Okay, increment voltage source, adjust, plus 250 millivolts. Okay. Voltage source is 0.250. Diode voltage 657 millivolts. This is 0.657. Okay. And current on green 93.2 microamperes equal 93.2 times 10 to the power of minus 6. Okay, enter this number. Very good. Go to the voltage source and adjust, plus 250 millivolts will be 1 volt. Okay, and 1 volt, voltage source 1 volt, diode voltage 688 millivolts, 0.688, enter. And current equal 312 times 10 to the power of minus 6. Okay, this number. Very good. And so on. Okay, do this for do this for on voltage source, do this for 1.25, 1.5, 1.75, 2, 2.25, 2.5, and so on. Increments of 0.25 volts. Okay. Okay, very good. I have this table. So I'm going to graph the characteristic curve of the diode. And I will use only these two columns, diode voltage and diode current. Okay. I will use XY dispersion. Dispersion with lines. And I will use this. Accept. The x-axis is the diode voltage. Okay, 0, 0.1 to 0.7. On y-axis, and y-axis is diode current. Okay, this is the characteristic curve of diode. This is the characteristic curve of the diode. X-axis diode voltage and y-axis diode current. Now you can see at voltage about 0.7, the current rises. Pause, rewind. Now remove the voltmeter, remove the so the voltage source, remove the voltage source, change to alternating current source, click here, AC, alternating current, place it here, join the nodes, click here and click here, click on the AC source and adjust DC voltage 0, amplitude I will change to 5 volts of amplitude, frequency only 60 Hertz, only 60 Hertz, only 60 Hertz, very nice. Phase 0, and should be a sine wave. Okay, sine wave. Okay, amplitude 5, frequency 60, DC voltage 0, phase 0. Okay, and change the value of the resistor to adjust 1 mega. 1 mega. Okay, 1 mega ohm. Okay, 1 mega ohm. Okay, move, drag the workspace, move here, and now run transient. Now you can see. Okay, very good. Space, rewind. I want to see the voltage here on this node. Click here on this node and click show waveform. and click on this another node, click show waveform. Okay, I want to see the voltage here on this blue nodes, and I want to see the voltage here on this another on this green nodes. Okay, so run transient and modify the simulation speed 333 microseconds per second. Okay, it's not real time. Remember, real time is 1000 milliseconds per second. Okay, this is not real time. I will adjust this to 10 milliseconds per second. Okay, this is the simulation speed, 10 milliseconds per second. Obviously, real time is 1000 milliseconds per second. Now you can see the rectification on green. Okay, and now you can see the peak for voltage source is 5 volts, but the rectified wave has 4.42 volts. Okay, I repeat, the maximum value of voltage source is the amplitude 5 volts, but the rectified wave has 4.42 volts. The difference is the diode voltage that is about 0.6 volts. The frequency is 60 in both cases. The minimum value for voltage source minus 5 volts, and the minimum value for rectified wave is about 0. Now you can do the following. Okay, pause, rewind, remove these nodes, and hide waveform, click again, delete, click here, delete. This is the diode, rotate. Okay, very nice. Enjoying the nodes, and run transient. Okay, space, rewind, click here, waveform before the diode, and show waveform after the diode, and run transient. Now you can see the simulation speed is 10 milliseconds per second. Now you can see the maximum value for voltage source is 5 volts. The minimum value for rectified wave is about 0, but the minimum value for voltage source is minus 5, and the minimum value for rectified wave is 4 point minus 4.42 volts. The difference is the diode voltage, that is about 0.6 volts, as you can see. Thank you very much, my friends.